So my name is Sam Rixert, and with my teammates Philip, Ian, and Nick, we made the multi-umbrella.
Our problem statement, obviously, Arizona is super hot. Because of this, people can get things like heat stroke. And so we just wanted to come up with a way to avoid this, and we thought we needed to cool people down. So our solution was to improve the umbrella. This will reduce the chance of heat stroke. The misters will help keep you cool, and the umbrella can be used regularly. So it can be used in the heat or to keep you dry from the rain. So this adds value to anyone who wears hats because they're trying to keep the sun out of their face. Our umbrella does the same design, and it also will cool them down. And our design is also has long-term usage because you can use it in the rain and the sun. So our customers, we wanted to start with college students at ASU looking to keep cool, and then we could work our way to buyers living in warm climate. So that could be anywhere in the world. And then our customers are all college students, so they would be able to give us good feedback. And then some key points. Like I said, it can be used in rain and heat. And then it allows a tech upgrade to a non-tech related product. And our product is a lot cheaper than other products similar to it. And then customer feedback, they talked about aeration, so we decided to add the fans and misters. Our design stands out because it also can open and close itself using buttons that are super easy to understand, and it's not a complex design. We wanted to make sure that it keeps users cool and can fit in one hand. Obviously, have the misting and fan feature, and then costs around $50 to be more affordable. And then this is our CAD model, which is a very simple design that's easy to understand and not over-engineered.
Okay, so here's the mechanical design of it. So the left image right here shows our pinion and our our pinion and our gear that we have for it. And on the back of it also is a wood plate to ensure that the motor goes in a vertical direction and that it's securely held in place so it will actually work. And then on the right image right here is our servo motor connected to our mister in order to make sure that our mister sensor properly worked. And so these are the mechanical designs that we have for this. We added in that wooden plate afterwards as well. Just some of the things we changed with the rack and pinion. We added a wooden plate behind it in order to make sure that it would properly go in a vertical path. And then also we added in a servo motor and a mister actually as well, a new mister, in order to make sure that we can actually get the misting power you needed and a way to actually activate it on and off. So this leads to our circuit. So our circuit pretty much with this, the top breadboard that is up here is for our buttons right here, which we had to rework and rewire several times in order to make it work effectively. And pretty much what happened is that we power comes from the bottom, ground comes from the top, and it works effectively now where if you press the button, power will be connected through, so it reads a 1, and if it's not pressed, it reads a 0 still. We also have a motion sensor, a servo, and a photoresistor all attached, which on the image on the right, you can partially see some of them. At the very bottom of the image, you can actually see the motion sensor in there. And if you look at the top of the image up here, that's where the photoresistor is, and they read light and they read the distance effectively, and we're able to get the numbers for that all. And then we also have a servo motor that is up near the photoresistor as well, that also reads as well. The only things we weren't able to include in this design on the left was actually the motors for them, but it's controlled by the L298N, and they would just be in circuit down here in the smaller breadboard, taking up pins 9 through 12 for those two motors. And then so some of the circuit changes we made was we added in a servo motor. We also rewired buttons to properly work because that was an issue that we had for a while. We were able to actually fix that and come over it. So here's some of the software code. See like the setup and everything, and then pretty much it tells you to like trigger everything and get all the states set up. And then if either of those buttons are pushed, there's going to be a motor going one way or the other, and then all the other stuff that happens, which is set right here. So if button 1 is pushed, the umbrella motor opens one way, and if button 2 is pushed, it opens the other way in order to open and then close it as well. We also have two sensors reading this. We have a distance sensor and a light sensor in order to get our values. And so if the distance is greater than 10, our fan is turned on, which pretty much if the umbrella opens up, it will sense that it's open instead of closed, and then it'll be able to turn the fans on for you. And also, we measured through trial and testing how much light level we should have. We decided on 200 in order to make sure that whenever it's like bright out, there will be the misters on, and whether it's dark, you won't have any misters on. And if both of those are on at the same time, both the fan and the servo or Mister Servo are on. But if nothing is turned on at all motors and actuators are turned off. And so the code is rewritten in order to have the servo included in it as well, because before we were just going to have a sprinkler system that connected to Arduino. We ended up moving it into a servo. The code is also made clearer and neater, and then we also properly coded in the buttons in order to make sure they worked as well. So here's 2 videos for our demonstration. This one on the right is the motor actually turning properly. So when we click it one way, it will turn one way. If we click it the other way, it'll turn the other way. Whichever way we tell it to press, it'll go the way it will actually go. On this left side over here, what we have is we have our fan working, and then we cover it up, and it shows to like stop working as well. So it's working effectively. It's a little hard to see at this angle, but you can see when somebody's hand goes by it earlier that it does work. And so that's our demonstration of it working. Unfortunately, our rack and pinion had too much friction, and it was too much in order to actually make sure that it would go up and down, which we noted in our demonstration. So the rack and pinion lacked power. The servo didn't work as it should have. And the light and motion sensors worked though, and the fan worked as well. But we tested this with iteration of code and wiring, and we tested with different components such as racks and gears in order to make sure we had the proper one, in order to make sure that we had what we needed for it to work properly.
Logistics and resources. Our umbrella covers the cost of $20 for the initial umbrella, $5 for the fan, $5 for the misters, and $2 for our motor. The sensors were also $5. The rack and pinion, which was the second most spendiest part, was $10. Our total budget comes out to be between $50 and $60. Logistics and resources, the physical build of our actual umbrella. The parts used were an Arduino. The quantity used was 1. Our rack and pinion was also used only once. Same thing for the umbrella, light sensor, motion sensor, and motor. The coding and wiring electronics was done by Sam Rixford. Wiring electronics and mechanical build was handled by me, Ian, and mechanical build was finished off by Philip and Mick Wage. Our entrepreneurial aspects of this idea. Is this a new concept? Is it not a new concept? I would say that this is not a new concept. It's not completely new, but rather it is an upgrade and it is an improvement to a current existing technology and model. The cost comparison and comparison to customer needs is pretty nice. The cost is roughly half of our competitors, and the size is compact, easily storable, doesn't get in the way and ergonomic, thus meeting customer needs, or in this case, students here at the university. This can be used in both rain and sunshine, as there are no compromises in functionality of both the original and the new umbrella. The summary of our idea is we learned how to work together and communicate. We learned how to use the design process to improve our design, to bring ideas together into life. We would communicate better next time. We would have a better motor, rack, and pinion, seeing as we lacked power in our initial prototype, a problem we should work to resolve immediately. Heat would always be a problem, but this is why we are working on said automatic watering umbrella to help reduce the problem of heat, and our solution is a practical and efficient and ergonomic way to combat this issue.